A short introduction to calibration, traceability, and accreditation. And unfortunately, this presentation is a bit text heavy, but I guess you survive. So, in case you have any questions, please contact me on matthias@bota.no. The picture here, by the way, is the international standard, or a copy, actually, replica of the international standard 1 kilogram. So, if you'd like to study that international prototype of the kilogram, study this article on Wikipedia. Calibration defined. What is calibration? Calibration is to compare your instrument to a norm, to another instrument. Obviously that instrument that you compare your instrument to should be a more accurate instrument. So you go one step up closer to the international standard. And therefore you shouldn't compare your instrument to just another instrument in your lab. Compare it to one that is certified. The purpose is to find out how much your instrument deviates from a correct value. And so therefore, of course, the instrument that you compare your instrument to should be a really accurate instrument. So for example, a scale may be calibrated in order to find out whether it shows the correct mass for a given object of known mass. So here you have, for example, 2 meters, and this is a true picture that deviates about 2 millimeters when you come to 165 centimeters. So this shows that the calibration process here clarifies how much these two deviate from each other. And if you are aware of that, if you're aware of that one is 2 millimeters shorter than the other, and you know, for example, that the upper one here is the accurate one, well, then you know that when you come to a full scale of, say, 2 meters, you should probably add at least 2 millimeters to your measure. But you can only find that out if you perform a calibration procedure. The calibration doesn't necessarily have as a goal to correct the instrument, but the result from a calibration should be that you document the accuracy by a calibration report or a calibration certificate. When is a calibration required? It's required for fiscal measurements, and there is a task today to study what fiscal measurements are, or fiscal measures. Some areas are regulated by law or regulation. There you have to have calibrated instruments. You have something called accredited companies and certified companies, and you have something called conformity assessments. We'll come back to all this on the next slide. And for example, if you have a final inspection according to a certain specification, then you need calibration and calibrated instruments. By calibration, the quality or accuracy in a measurement or an instrument is documented. That is the whole point. To document the quality of the measurements made by your instrument. The tolerance of the documented accuracy may be specified by. So who specifies how accurate an instrument should be? You could have your own requirements. The customers could have requirements. Third parties could have requirements. Standards, governments, and the list goes on. This here is my source. Here is a company called IKM Laboratorium AS. Accreditation. That is an independent assessment of a company's competence, integrity, and independence. So I can have an accreditation from another company or board that comes and looks at my company and find if we have the competence needed, if we have the integrity, if you can rely on us, and if we are independent, or are we truly dependent on something like another government or whatever. Certification is a formalized form of evaluation that has as a goal to issue a certificate. So you can have an accreditation certificate, and then you have to go through a certification process in order to get that certificate. The certificate is a proof that the competence management system, product, or a service is according to relevant standards, regulations, or industry requirements. Conformity assessment involves a set of processes that show that a product, a service, a system meets the requirements of a standard. So the conformity assessment is a test or kind of an exam for a company. Accredited calibration versus a non-accredited calibration. The accreditation is an official approval of an organization's competence and ability to perform a given task according to given requirements from an internationally approved accreditation organ. So you have someone that performs the accreditation, and in Norway we have something called Norsk Akkreditering, the logo here. That is a government-run board that does this process. And the accreditation itself is the proof that the calibration process is performed according to approved methods and that the organization is competent. So this board here visits a company and do the accreditation and say that this company is competent and can act according to the requirements. A non-accredited calibration has no official approval, so I can, of course, calibrate my instrument in the lab, but if I want a certificate of my instrument, I need to go via the chain of accreditation. This is important. What is the difference between accuracy, trueness, and precision? And if you read like 10-15-year-old books, you will see that this was split into two. You only had precision and accuracy. Then the precision was the ability to measure the same thing always, and accuracy was the deviation from a reference value or the true value. Now that has changed. The new ISO definition is, and is according to ISO. ISO is International Standards Organization. So ISO 5725 states that you have the accuracy that what used to be called the accuracy should be called the trueness. Precision is the same. Trueness is the degree of systematic deviations from a reference value. So if you have this is the true reference value, all your measurements are this far up, then this is the trueness of your system. The accuracy is one measurement's closeness to a reference value. So if I have one measurement that is here, like that, that is how close is that one measurement here to the reference value here. And why does it land here? Well, it's the result of two things, the trueness and the precision. That's why it's here. On the y-axis here, you have the probability density. That is, how probable is it to find your measurement somewhere along the line here. So the accuracy, important, it's one measurement's closeness to a reference value. And it's the result of both the above, both the trueness and the precision. So if you say here, forget that one, forget forget this here, keep an eye on this one, the ISO definition. You have good precision or poor precision. Good precision means that all the shots are collected in a narrow cloud. If you have poor precision, your shots are spread all over the place, like that. If you have good trueness, then the average shot is in the center of the bullseye. If you have poor trueness, then your average shot here is a bit off from the bullseye. You have good trueness here, but your shots are spread because of the poor precision. But the average is somewhere about in the bullseye. Here, the average is up in the corner, and the precision is not good as well because the shots are spread all over the place. Traceable calibration. With traceable calibration, we mean that calibrations have been performed in an unbroken chain that relates your instrument to a national or an international norm, and where each link in the chain have documented measurement uncertainty. So, if this is your instrument here, you compare that to a better instrument. That in turn is compared to an even better instrument, and all the way to the international standard here, like the kilogram standard that we looked at the very beginning. Traceable calibration is offered by something called Justervesenet in Norway. Traceability means that it can be tracked back to its origin, so I can find that my instrument was compared to that very instrument there, instrument number 62B for example, that was compared to, and all the way back there. How should this traceability take place? Well, that's usually specified in a national or an international standard. So the higher up the chain you are, this is the definition or the international standard. It has a very low uncertainty. Further down you have a higher uncertainty, which means that you have a better accuracy on top and lower accuracy or poorer accuracy at the bottom. The norm should have an accuracy that is 3 to 5 times better than the object of calibration. So make sure that your calibration, the instrument that you calibrate against is actually much better than your own instrument. In that way, you guarantee that you are close to the ideal world here. Here again, the pyramid here. The pyramid shows that the volume of each floor gets smaller the higher up the pyramid we get. So there are fewer instruments the higher up you get. In the different labs around the world or around Norway, or you have a lot of instruments. Quite a few, maybe even on. So these are the ones that we use on the plant. There may be on the plant one working standard. So you may have one instrument that you use to calibrate all your instruments in the field. So you have working standard, and then maybe even a reference standard, and then you go up to someone else which has an accredited calibration standard and a national standard, and then the international standard. Calibration is not the same as adjustment. To calibrate is just to find the value, see if it's correct, and to learn the weaknesses of your systems. To adjust is to try to correct the value. But you don't always do that. Sometimes you only calibrate to find out how accurate your instrument is, but sometimes you also adjust. Not always. And then you verify by calibrating again, and then you go around and round in this wheel.